Hey, what's up guys, it's Roosevelt Williams with TinkerPro, and in this video I want to share with you a project I completed recently. Almost 2 years ago, one of my friends purchased a portable monitor to use for his PC setup. It was a 15.6-inch Lepow portable monitor, and it came with quite a few accessories like a mini HDMI cable, screen protector, wall charger, and more. It was a pretty nice monitor for its price, but it had one flaw. The monitor stand wasn't the best. It lacked mobility and it wasn't elevated, so it was relatively low in comparison to a regular monitor. On top of that, it was very difficult to get the stand in its correct position, and there weren't any instructions shown on how to properly set it up. One positive note about the stand, however, is that it also serves as a case for the monitor, which I thought was pretty cool, but that didn't stop my friend from asking me if I could design a more reliable stand for him to use as a replacement. Now, of course, I would have been more than happy to design a solution to his problem, but unfortunately I had other projects taking all my attention at the time, so I never got around to putting anything together for him. After several months of frustration, my friend decided to buy a regular monitor, one that wasn't portable, and he tossed the Lepow screen to the side. He later passed it down to me, and I accepted it gratefully, completely forgetting why he didn't like it in the first place. Within 48 hours of having the screen, I was over it, and I began brainstorming ideas for a new stand design. A design that would at least elevate the Lepow screen to a more comfortable height. At first I was going to design something nice and simple, but then I thought, nice and simple would be boring. So I decided to push the envelope, and I started doing research for inspiration to design a screen mount instead of a simple stand. During my research, I remembered helping my friend install mic arms in his studio several days prior. I remembered assembling the mic arms and thinking to myself, I bet I can design something like this. It was something about the build and ease of use of the mic arms that caught my attention. Or maybe I just enjoyed assembling them. I don't know, but I knew I liked the concept. They were Vivo pneumatic mic arms, and they were pretty simple to install. I just knew I wanted to design something similar someday, but I didn't know what for at the time. I borrowed the mic arm from my friend to take some measurements and learn a little bit more about its functionality for reference. One thing I noticed right away was the material difference. The mic arm was made of mostly metal components, whereas my design would be mostly plastic. So I knew in order to design a mount that would be durable enough to stand the test of time and maintain its functionality, I would have to beef up my dimensions in comparison to the mic arm. My design started with the base, the area where the mount would clamp onto the desk. I pondered over the base clamp design a lot because I wasn't completely sure if a plastic 3D printed clamp would be a reliable foundation for my design, or if it would even work effectively in comparison to the metal clamp of the mic arm. I did some research on 3D printed clamps to reassure myself on the feasibility of my design, and I found some interesting information, but I knew I wouldn't know for sure until I gave it a try on my own. The base clamp began as two simple components, a fixed jaw and a lower frame. These were the first and second components of the design. As the design progressed, I began adding details like the screw holes to mate the fixed jaw to the lower frame, and other design features to mate with future components. The third component of the clamp design was the adjustable screw. The fourth component was the movable jaw. I added some details to the movable jaw, but those details would be adjusted later in the design. There are 3 evenly spaced 1/4-inch counterbore screw holes at the bottom of the fixed jaw to mate with the shaft. The shaft is a component I will talk more about later in this video. As a placeholder, I designed the shaft components and made a handle for the adjustable screw. For the handle, I made a triangular star type design. It looked comfortable and it had an interesting aesthetic. I added a single screw hole through the neck of the handle to mate with the adjustable screw, which you will see later in my process. I then added threading to the adjustable screw and the corresponding threading to the lower frame. After doing some research on common threads for clamps, I chose an ACME screw thread, but I later switched to isometric threading because I felt like it would give me less trouble during the 3D printing process. Once the threading was in place, I took some steps back in my design to improve the structure of the inner right angles of the fixed jaw and lower frame. My goal was to add material to these areas to make the components stronger and more reliable so they won't break as easily under pressure. I also wanted to add some aesthetic details to the inner angles to improve the design, but in order to maintain structural integrity, I could only go so far. After that, I added more details to the screw holes that mate the fixed jaw to the lower frame, making the counterbore wider to include a washer and placing recessed pockets to the back of the fixed jaw for corresponding nuts to be inserted. Unsatisfied with the aesthetic details I made earlier, I went back to make changes to the inner angle again. After that, I added more details to the handle as well. The handle mates with the bottom of the adjustable screw using a single screw and nut that goes through both components to hold them together. The adjustable screw mates with the movable jaw also using a single screw and nut that goes through the top of both components. The nut that's used to mate the movable jaw and the adjustable screw is inserted in the top of the adjustable screw, and the connection is made internally. You'll see more of what I mean later in the video. Once all that was done, I started adding .03 fillets to every visible edge of the components that I considered complete. I added isometric threading to the shaft components to mate them together. It served as a placeholder because I wasn't 100% sure how I wanted those components to mate at the time. Uncertain of my design, I went back to add a third screw hole to the lower frame to mate with the fixed jaw because I figured the more fasteners, the better. I also added more details to the fixed jaw. I made 4 half-inch diameter indents to the bottom face of the fixed jaw to place Gorilla Grit self-adhesive bumper pads in each indent. I did the same thing for the movable jaw, removing the details I added in the beginning of my design. The purpose of the bumper pads was to help the clamp grip the desk without sliding around. You'll see what I mean later. Finally, I added my name to the outside face of the fixed jaw because if I liked it, then I should have put my name on it. Now that the base clamp design was complete, it was time to print it out, assemble it, and test it. As planned, I began printing out each component of the base clamp, and everything was going smoothly until catastrophe struck. I started getting this print fan error message on my 3D printer. Since the error message began to occur more frequently, I was left with no choice but to change my print fan. And for the curious viewers, you can learn more about how I changed my print fan in my last video. After changing my print fan, I was able to finish printing out the 5th component of the base clamp design, which ironically was the last component to complete the assembly. I added the Gorilla Grit self-adhesive bumper pads to the indented spaces of the design, and I clamped the design to my work desk for the first time, but the results weren't what I was expecting. Right off the bat, the lower frame began to separate from the fixed jaw the tighter the clamp got, even after adding the 3rd screw at the last minute, thinking it would help keep those components together. The fixed jaw wasn't completely parallel to the surface of the desk for some reason. It was raised slightly at the front end of the clamp. When I looked underneath the desk, I could also see that the movable jaw wasn't completely parallel to the bottom of the desk either. It was pressing against the desk on one side, just like the fixed jaw. To top it all off, the outside face of the fixed jaw started to bend drastically as the clamp got tighter to the desk. The results of the first base clamp design were not what I was expecting, and I had no faith in the design's ability to stand the test of time. I wanted a base clamp design that would support the load of other components as well as the Lepow screen while remaining structurally sound. I took some time out to do some brainstorming to come up with solutions to the issues discovered in the first base clamp design. Several weeks later, I was back to the drawing board with a fresh mind and newer ideas.